Okay, so try number 5. So square root of negative 16? 4i, right, because square root of 16 is 4, and the negative inside makes an I come outside. Now, the 245, some of your calculators will do it automatically. I'll do it by hand. 5 times 49? It's the 49. We just keep doing the 49 thing everywhere. 7 times 7. So that's going to be square root of 5, 7 times 7. 2 7s in, sends 1 7 out, and they're gone. So 7 square root of 5, is that good? So then this has to become plus 7 square root of 5, and then I because of the negative. There we go. Oh, and it wants, okay, yeah, I'll show you what they want there. Well, no, they'll take it just like that. Yeah, no, just like that. Well, no, I think when they both have I, they want you to write it 4 plus 7 root 5 I, like that. Factor the I out. That's right. That's what they want you to do. Is that good there? Does that make sense what we did? I want you to factor that I out. I think the last one as well. Let's look back for a minute. So yeah, so there's those other ones. Did we do all those okay? Yeah, we factored the I out. Yeah. So there's the first 4. So yeah, there they are. That's how they work. So basically what you always do with a negative inside of a root is you pull out an I. So if you have a negative in the front, that just means a negative in the front. If you have a negative on the inside, that means an I. So same thing here, square root of negative square root of negative 49. Negative on the outside stays on the outside. Negative on the inside becomes an I. And then you just do the square root of 49, which is 7. Yeah, question?
Why is this a problem where it's just a negative on the outside, root, and then the number inside is positive?
Yeah, so like what if we had negative square root of 9, just a negative on the outside, no negative on the inside, you mean? Yeah, that negative on the outside would just stay on the outside, and the square root of 9 would just be 3. No I on that one. Yeah, I only comes when there's a negative inside. Good question, good clarification. So negatives on the outside just stay outside. They never make an I. Only thing that can make an I is negatives on the inside. We good there? On that. Now they're going to take real numbers and combine them with imaginary. See how they're putting them together? They're having like a plain old 8, which is a real number, and then minus 8i, which is an imaginary. When the real world gets together with the imaginary world and they put them together, that's called a complex number. That's the title of this section. So a complex number has a real part plus an imaginary part. We say A plus BI. See how they say it right there? Write your answer in the form A plus BI. That means real part and imaginary part, right? Part that has an I next to it. So that's called a complex number because it's not simple. It's complex. It's made out of real part and imaginary part. There's a whole world there. We're at just the tip of the iceberg. Underneath the water is a whole world of complex numbers, they call. They have classes on complex, like the whole class, there's whole fields of math studying this area and all kinds of real life applications of them. Okay, but we'll start off pretty easy. So we have this new creation, and it really is, they just made it up because it's useful for things, called complex numbers. And so when you make up something new in math, that's what they do all the time, they make up new things, you have to make up the rules for how you add those things, subtract those things, multiply those things, and divide those things. Add, subtract, multiply, and divide complex numbers. How do you add, subtract, multiply, and divide two complex numbers? Let's start with adding. How do you think you add two complex numbers. If you were making it up, what would you say to do?
Eyes and real numbers.
That's what they did too, Claudia. You could have been with them on this. You just add, yeah, just like terms. Just add the real part with the real part and the imaginary part with the imaginary part. Exactly. So I say it's an easy section. So 8 and 7, 15. And then minus 8i and minus 6i, minus 14i, done. Just real with real, imaginary with imaginary. Now, what do you think you do on this next one where we're subtracting? So that was adding, now subtraction. What do you do when there's a negative in front of any parentheses? Yeah, so go ahead and distribute through the parentheses on the right. Like always, changing the signs and then just combine like terms. I'll let you crank that one out. The minus 9 distributes, minus 9 minus 6i. Good so far. That negative distributes through the parentheses. And then real part with real part, 4 minus 9. Negative 5. And now minus I and minus 6. So there's an imaginary 1 in front of that. Minus I, huh? Minus 1i and minus 6i. Minus 7i. And we're done. Is that good? Questions I can answer? What is square root of 3 squared? Yeah, it means two of them, and 2 3's in, 1 3 out. Or you could just cancel from the beginning, it's just 3. Either way you want to do it, right? You all with me on that? Right? Because a root and a 2 power literally cancel each other out, and whatever's inside just comes out. Huh? We had a 3 inside, it comes out because it's 2 of them. And 2 3's in, 1 3 out. Okay. So what about root 7 squared? Yeah, it's going to be 2 of them, 2 7's in, 1 7 out. Easy, easy. Okay. So let's think about, let's go back to our square roots. What's the square root of negative 9? 3i. We all good with that? Because the square root of 9 is 3, and the negative inside leads to an I outside. What's the square root of negative 4? 2i, because the square root of 4 is 2, and the negative inside is I outside. Okay, what's the square root of negative 1? 1i, or just I. Huh? You agree? Because the square root of 1 is 1, and the negative inside is the I outside. So, what's going to be, here? So here's the real question now. What's going to be the square root of negative 1 squared? What do we say happens here when you have a root and a square? Doesn't that mean 2 of those? 2 negative 1's in, 1 negative 1 out. Right? And these cancel, right? Or another way to say it, same thing. Well, hold on. What's I? So this is I squared, isn't it? Because square root of negative 1 is I. So square root of negative 1 squared is I squared. And what does I squared equal? Negative 1. We just worked it out right here. So I squared must be plain negative 1. Did you track with that? So I squared is plain negative 1, not imaginary, in other words. That's weird, isn't it? How the imaginary world intersects with the real world. Weird. I squared is a real life negative 1. It's not imaginary anymore. There's no I over here, is there? I squared is a real life negative 1. I squared is negative 1. So, let's get back to the question. So what? Okay, well, how do you do this question then? What did we learn? What do you do with a negative inside a root? Kicks out an I. Can you square root 7? No. So it just says square root of 7, but the I comes to the outside, right? The negative inside kicks an I to the front outside, doesn't it? So far, so good? And what does the negative inside the root 10 do? Kicks an I outside, and you just leave the square root of 10. Good. So far, these are timesed, right? So far, so good? I just took both those negatives inside and kicked i's outside. So now how do you multiply this? Well, square root of 7 times square root of 10 is just square root of 7. You write insiders with insiders, as we learned last week. And then what's I times I? Well, I squared, just like, bless you, just like x times x. Am I going too fast? Is this good so far? Negatives inside kick i's to the outside, and I times I is I squared. It's like x times x. Square root of 7, square root of 10, square root of 70. And then what did we just agree was I squared? Yeah, I squared's negative 1. So that means whenever you see I squared, you never leave it because it's a real life negative 1. So this means this is square root of 70 times negative 1, which is just negative square root 70. That's the answer to that problem. So those two imaginary numbers multiplied to make a real number. Isn't that weird? A number that's no longer imaginary. So let's try number 10. Let me get y'all good on that one. Let me rewrite 10 for you. And write out the rule we've seen. 7i times 3 minus 6i. I squared, we never leave I squared, but replace it with negative 1. I should say, we leave regular I, but we never leave I squared. So regular i's we leave. I is just I, it's just imaginary, leave it. But we never leave I squared. We replace those with a negative 1. So try that problem, just normal multiplication. 7i is going to multiply those two. So 7i times 3, 21i minus 7i times 6i, 42i. So far, so good? That was just normal multiplication, right? But the regular I we leave, so that'll just stay 21i, no big deal there. But what do we do with I squared? Negative 1. We never leave I squareds. We replace them with negative 1. So that's 21i plus 42.
But wouldn't it need to be flipped around?
Yeah, they do. They want you to write the real part first. When you type in the answer, you're right, thanks. They want the real part first and then the imaginary when you type in the answer. Yeah, correct. That's how they want the answer. Does that make sense what happened there? So we're just multiplying like normal, just like you would with an x or anything. But when we get I squared, we never leave it as I squared. We replace it with negative 1. Okay, can you FOIL that out? Let me make it give you a little more room here. 7 plus 5i, 8 minus 2i. Okay, so try that one. Do the normal FOIL, but if you get I squared, replace I squared with negative 1. So here we go. This 7's going to go to both. 56 minus 14i plus 40i minus 10i squared. Good so far? Just normal FOIL. And now, these two in the middle are like terms, aren't they? So they'll combine 40 minus 14, what is that? 26. I. And then what do we do? That's not 40, 10. And then what do we do with I squared? It becomes negative 1. Do you see what happened there? I leave I as I, so the plain I just stays I. But the I squared I don't leave, I replace it with negative 1. Like that, are we good? Everybody see what's happening there? So then, now what does that do? Well, this is 56 plus 26i. Now minus 10 times minus 1, because that I squareds become negative 1. We never leave I squareds. They always become negative 1. We leave plain I. This becomes plus 10, doesn't it? And 56 and 10? 66. There's our final answer. 66 plus 26i. How are we doing? Is that making sense? I squareds we never leave. We leave the plain I, but I squareds we never leave. We replace them with negative 1. All right. All right, so try that one. Six plus 8i quantity squared. So what do you do when there's a 2 on parentheses? Double it, right? 2 of them, right? Yeah. Exactly. 6 plus 8i. 6 plus 8i, exactly. So go ahead and FOIL that out. Okay, so this 6 goes to both. 36, 6 times 8, 48. I, he's done. And the 8 goes to both. 48 I plus 64 I squared. All right, and then these two in the middle, what's that, 96i plus 64. And what do we do with I squared? Negative 1, right? We never leave I squared, but we always replace it with negative 1. We leave the plain i's, but I squareds are negative 1. And so that becomes 36 plus 96i minus 64, doesn't it? And 36 minus 64 is some number I don't know. Minus 28? Thank you. And there we go. Minus 28 plus 96i. These making good sense? Not too bad? Weird, huh? But not a hard section. So we have one thing left in this section. We've added, subtracted, multiplied. Right? This is a multiplication of 2 complex numbers. And now we need to divide 2 complex numbers. That's the hardest. Okay, so last operation. We've added, subtracted, multiplied, and now we're dividing 2 complex numbers. How do you divide 2 complex numbers? Well, you know what it's like? It's just like square roots, which you just learned. So, because remember, what is I? Back over here. Remember where we found I? Where are you, I? I, what is I? Square root of negative 1. So an I is a root, really, isn't it? It's the square root of negative 1. So what? Well, that means when you see I, you know what you should think? It's just like 8 minus 4 square root of negative 1. I mean, that's what it is. 4 plus 8 square root of negative. That's what I is. Now, you don't need to write that. I'm not saying you actually write that. But just think it in your head. Just think, hey, I'm looking at a square root. That's what an I is. It's a square root of negative 1. Okay, how would that help you? Well, just last week, We did problems with square roots and pluses or minuses in the denominator. Remember what we learned to do about those? You multiply by exactly the denominator, this exactly, except opposite sign in the middle. You would multiply by 4 minus 8, and 4 minus 8 square root negative 1, huh? That's exactly, so you don't need to do any of this. But I'm just saying, think of it that way. We're going to use the conjugate, right? Because an I is a square root. So you're going to multiply. So when you have I and plus or minus, in the denominator, multiply by the conjugate, it's called, which means same as denom, opposite sign in the middle. Opposite sign in the middle. So what goes in the middle? Exactly the denominator, but opposite sign in the middle, negative. Is that making sense? It's just what we did last week with square roots. An I is a root. So an I with a plus or minus is a root with a plus or minus. So that's how you divide. You do the conjugate. So now let's crank it out. So we're going to FOIL the top. We're going to FOIL the bottom. So try carrying out the FOIL on the top and the bottom, and I'll finish it up in a second. All right. I hope that's coming out for you. Let me jump in. So what do we get? 32 minus 64i, and then minus 16i plus 32i squared all over on the bottom. 16 minus 32i plus 32i minus 64i squared. That good to there? Everybody good to there? See what happens on the bottom? See how these two cancel? The minus 32i and the plus 32i. That's what always happens. That's why we multiply by the opposite sign. That's how that always works. Right? That's why we did the opposite sign, because we wanted that to happen on the bottom. So what happens on the top? We've got 32 minus 64i and minus 16 is that 80? 80i plus 32. Now what do we do with I squared? Change it into negative 1. On the bottom, we have 16 minus 64, and then I squared, this one also, negative 1. So those I squareds on the top and the bottom both become negative 1, don't they? Everybody see what happened there? Did everybody see how these two canceled out? And so where does that leave us? 32 minus 80i minus 30, right? Plus 32 times 8 was minus 32. The bottom 16 plus 64, right? Minus 64 times minus 1. 32 minus 32 minus 80i over, what's that, 80? That's minus I? Look at that. That means this big mess they started us with is a fancy way to say minus I. That really simplified, didn't it? Does that make sense? What happened? So it's minus I. Oh, by the way, they want you to give the answers. They'll say answer answer in the form A plus BI. So they want you to give real part and then imaginary part in your answers, because a complex number, right, has a real part and an imaginary part. You think, yeah, but all we've got's an imaginary part. Right, so it goes 0 minus I, and they'll be happy. I believe. Is that right? Do they want you to type it in that way?
Yeah.
You have to put in the actual 0. Do they do 2 different boxes? Is that what they do?
No.
Just like that.
Yeah.
Okay.
You have to add.
Do you have to actually put the 0?
You don't put it there.
Okay, so I'm being exaggerating. No, so just negative I is good enough. Did that? They assume you mean the front is 0. Good. All right. Let's leave it like that. That's good. All right. 6i over 17. 6i over 9 minus 8i. Okay, so try that one. Same kind of thing, right? You got an I. You got an I, which is a root, and a plus or minus on the bottom. So you know what you need to do. You need to multiply by the conjugate, which means exactly the same as the denominator, but opposite sign in the middle. So we're going to multiply by exactly the same as the denominator, but opposite sign in the middle, right? So 9 plus 8i over 9 plus 8i. So carry out the FOIL top and bottom there. So I get 54i plus 48i squared. And then on the bottom, 81 plus 72i minus 72i minus 64i squared. These cancel on the bottom. Right? See how that always happens when you use the conjugate? You always get those. That's why you use the opposite sign, to make that happen. So what do we get now? 54i plus 48. And remember what we do with I squared. Negative 1 on the bottom. Again, I squared, negative 1. So then we get 54i minus 48 over 81 plus 64, which is 54i minus 48 over, what is that? 145? 145? So, get to there, and write that again. Is that good? Everybody good to there? Are we done?
No, because the real number has to be in front.
Right, you have to separate them. Good job, Claudia. Yeah, they want us to separate those where we put the real part in the front. So let me get this out of the way. So they want the real part and then the imaginary part. Remember, that's what they'll say to you. They want A plus BI. So let's separate those two. So we have 54i over 145 minus 40. See, first off, you need to separate those over a common denominator. Then you got to switch the order because you want the real part in front, the imaginary part, the I part in the back. You tracking with me? See how I divide? They're both over 145. So I separated them each separately over the 145. So then it'll be minus 48 over 145 plus 54 over 145i. See how I swapped the order? Remember, when you move things around, you take their signs with them. So this negative, that's his baby. So when you move him to the front, that negative sign goes with him. And what's in front of the I fraction? Nothing, which means positive. So when you move him, his baby goes with him as well. His plus sign that's in front of him, his nothing that's in front of him, goes with him. Right? You You good so far? Why did I do that swap? Why am I swapping the order there? Because they made me. They say put the real part first and the I at the back, please. So I had to move the I to the back. Is that making sense? So I put that I at the back and the real part in the front. And then we got to reduce both those fractions, don't we? So see how they're being kind of picky here in the way they want the answer? I don't want you to get messed up trying to do your math Excel homework and get to here and think, I did it. Right? They want you to separate the two with a common denominator and then put the real part in the front and then reduce the fractions. So what goes into these? This is divisible by what? 3? Minus 16 over 49? No, I don't know what that is. Oh, it's not divisible by 3, is it? No, it's not. That one's not reducible, is it? No, 3 doesn't go into 145. What was I thinking? What's that? Yeah, they don't want a decimal. Yeah, so we can't reduce the fraction. The other one, nothing goes, yeah, no, they're done. We're done. They're not reducible. I'm totally confused. We're done right there. Those fractions are not reducible. We just had to separate them and put them in the right order. The real part first, the I at the back. That's how they want the answer. We good on that? That making sense? Questions I can answer? Let's do maybe one more in this section. Now, when do we have to do this whole opposite sign in the middle thing? Not a root in the bottom or an I. There's more to the story than that. And that's the crucial part I want to make sure you're getting. So how about I write it? So it's when you have an I and a plus or minus. Remember the glue. It's got to be glued. Or you don't, this whole thing is only required because of the glue. So I want to make sure you're all clear there. Because they're about to give me ones without a plus or minus, and you don't need to do this whole thing. So you tracking with me? So when is the conjugate required? When things are glued. One of them being a root or an I. I is a root. So when you have an I or a root and the glue and the plus or minus, right? That's why I'm saying that. When I and plus or minus are in the denominator, that's when you have to do opposite sign. It makes sense. If there was no plus or minus, there wouldn't even be a sign to do opposite of, right? So that's where, I'll write it bigger for you. 5 minus 7i over 2i. We're going to go 5 minus 7i over 2i. Can you, do you see how this one does not have a plus or minus? When the denom only has I, no plus or minus, then simply multiply top and bottom I over I. You don't even need the 2. It's not glued. That 2's not glued to the I. I don't need that 2. All I need on this one is to multiply top. We always do the same thing top and bottom, right? Because we can't change the fraction. But all I need is to multiply top and bottom by I. Everybody see the difference? The only time you need to use the whole denominator is when it's all glued together, the plus and minus, then you use the whole denominator opposite sign in the middle. But if it's just an I down there with no plus or minus, just multiply by I. Can you carry the rest of that one out? All right, let's carry it forth. So this I will go to both those, right? So we'll get 5i minus 7i squared on the bottom. 2i times I. 2i squared. What now? Yeah, these guys become -1, don't they? We never leave I squared. We leave plain I, but we never leave I squared. So that's going to become 5i minus 7 times -1 over 2 times -1, right? Both those I squareds become -1. and that's 5i plus 7 over negative 2. Good so far? Can we leave our answer like that?
No.
Got to separate them, right? Because they want them separate with the real part first and the I at the back. So when I separate them, that's 5i over negative 2 plus 7i over negative 2. No, what did I do? I made up a new I that wasn't there. Good to there. I just separated them, and now I got to swap the order, don't I? Because they want the I at the back. So it becomes 7 over negative 2 plus 5i over negative 2. And that's actually fine. Probably you'll more commonly see they don't usually leave negatives in the bottom. It's okay. There's nothing wrong with it, but I'm just telling you on a multiple choice test, a couple weeks, they'll put those in the front. You know it's all the same, right? You'd see them, it'd look like this. Minus 7 halves, minus 5 halves. That's the same answer. Would you realize that in a multiple choice test? See how the negatives on the bottom, they just yanked them to the front. They just, whatever reason, don't like to leave negatives on the bottom usually. It's the same answer. Now it's like they want real part than imaginary part.
Can you just write it as 7?
Plus 5i over 2.
Yeah. Can you write it like that, or would it be wrong?
With the plus there, just like that?
What you're saying
Just
just 17 on the bottom.
with a single 2 in the bottom.
No, because that wouldn't be separate. Like I had right here. Whoops.
Okay, so you have
Like right here. Yeah, because you have to separate them. Yeah, they want them. They don't want one fraction. They want two separate things. So we have to separate them. Is that good? Is that making sense? On that, are we comfortable with that? You see the difference then for when you have to do the whole conjugate thing and when you just multiply top and bottom by. It's the same rules for roots that we did last week. It's all about if you have what makes everything hard in algebra? Pluses and minuses, huh? So when do you have to do the whole hard conjugate thing? When you got a plus or minus, of course. So if you've got, so like this last one, we had the I and we had a minus sign. So they were glued together. I had to use the whole thing, opposite sign in the middle. But this one, I just have an I. They're not glued. The 2 and the I are not glued. I just used the I, and it was all good.